Hello and welcome to the EHDemo Expo poster presentation. The EHDemo team consists of Lee Melton, Parker Schmid, Jason Cook, Garrett Dixon, and Daryl Thomas. Our industry supporters are Nicole Ott from Anderson Hauser and Scott Rice and Casey Fisher from Caratech. Our faculty mentor and grader is Dr. M. Gary Hodgins. The objective of the project is for the students to design, build, and test a fluid flow demonstration apparatus, which will replace the outdated one that is currently being used for the thermal fluids lab. Through several experiments, the apparatus will show the properties of flowing fluid through a network of copper pipes using multiple sensors to collect pressure, temperature, and flow rate data. A control panel will be used to operate the motor and solenoid valves remotely. The frame is made up of variously sized A36 square steel tubing and angle iron and has been primed and painted to protect the members. The pump for the system is a three-phase 240-volt centrifugal water pump that can provide a max head of 83 feet, which is connected to a variable frequency drive which will control the speed. Most of the piping for the system is made up of 1-inch copper piping, and a small section connecting the tank to the pump is made up of a larger diameter PVC pipe. Copper tees with barbed hose adapters are used as pressure taps for the system. The system employs solenoid valves, ball valves, a globe valve, and a check valve, all of which are supplied by and donated by Caratech. The system uses differential pressure sensors, an electromagnetic flow meter, compact thermometers, and an absolute pressure sensor, all of which are donated by Anderson Hauser. The control panel for the system was constructed with the help of Caratech and has switches to remotely control the solenoid valves and a controller for the VFD. An emergency stop switch is also located on the control panel. The system is also able to connect to a computer so it can be controlled using LabVIEW software. A National Instruments DAC is used to collect data and was donated by UNC Charlotte. The system is capable of performing 3 experiments: a pipe friction experiment showing head loss along straight pipe sections, a flow rate experiment using an orifice plate which creates a sudden change in pressure, and a microturbine experiment which demonstrates how mechanical energy can be turned into electrical energy in hydroelectric systems. The allotted budget for the project was $3,000, and thanks to the generosity of Caratech and Anderson Hauser, only $2,553.31 was used. Immediately following the Senior Design Expo, the apparatus will be handed over to the UNCC Mechanical Engineering Lab Department so beta testing can happen over the summer and the system can be fully implemented in the fall. Software, manuals, and documentation will accompany the apparatus when it is donated.